In today's lesson, we are going to be looking at another type of word problem, specifically distance, speed, and time word problems involving linear systems. So again, this is another kind of group of questions that you might come across that might be a little bit trickier in terms of coming up with the equation. So we're going to look at a few examples to kind of help us become more familiar with them. So in our first example, a canoeist took 2 hours to travel 12 kilometers down a river. The return trip against the current took 3 hours. What was the average paddling rate of the canoeist, and what was the speed of the current? So here we're trying to find two things. We're trying to look for the speed of the paddling and the speed of the current. So how fast was the boat going based off of just paddling, and how fast was the water carrying the person or the canoeist? So these types of questions are always going to involve some form of a distance, speed, time formula, right? So if we remember back in grade 9, we did look at distance, speed, and time graphs, and we had that speed is equal to distance over time, right? Or velocity. So speed is equal to distance over time, right? So this is the formula that we're going to be basically using to help us come up with their equations. Now it could be some variation of this. So maybe you learned in science where we have speed or velocity is equal to distance over time. We have our little triangle, and we can use this to figure out other equations. And how it works is basically you cover up what you want to find, and then the other, then whatever's remaining is the formula. So for example, if I want to find distance, I cover up distance, and I have speed and time together, or velocity and time together, so that would be multiplying. If I wanted to find speed or velocity, I cover that up, and I have distance over time, or distance divided by time. Same thing with if I wanted to find time, time is distance divided by velocity. So that's how that kind of triangle works. Actually, make it a little bit neater. So you could use that to help you come up with the different equations that you may need for these formulas or for these solutions. So our first step is to figure out what are the variables. And we have two things that we're going to be looking at, right? So we're going to let x, or let's let p equal the speed of paddling. So just the canoeist alone, how fast were they going? And then we're going to say let r equal the speed of the river or the current. Once we come up with these two equations, we can use, or once we come up with the two variables, we can now try to come up with the equations. And when we come up with these equations, it's really going to be helpful to create some sort of table like this, right, where you have your distance, speed, and time all calculated out. Right, so we're going to have two parts, two directions. Right, one is downstream. So downstream means we're going with the current. And then we have upstream. So upstream means we're going against the current. Now we need to figure out some pieces of information. Right? What is the distance that they traveled? Well, it does mention that it's a 12 kilometers down the river. So they're going 12 kilometers down. And then the return trip would be going back 12 kilometers. Speed is going to be a little bit different, so we're going to come to that in a second. Time, right? We know it took 2 hours to go down, and we know that it took 3 hours to come back. Now we have to come up with our with the speed. And we have to keep in mind that when we go downstream, we're traveling with the current. So our speed is going to be that of the paddling plus the speed of the current, right? So we're going to go faster downstream. And going upstream, it's going to be the speed of the paddler, but we're going to subtract the speed of the current because we have to fight against that. So that's going to be trying to push us in the opposite direction. So we have to subtract that from our speed to figure out what the actual speed of that trip would be. And we're going to use this to come up with our two equations. So what we're going to be doing is we want to basically try to solve for our our speed. Right? So if I go back up here, if I want to try to find speed, I have my formula speed is distance over time, and I have a distance in time. So my first equation is going to be to try to find the speed of downstream. So I'm going to have speed, which is P plus R, is equal to, or actually let me write out the formula. So we're going to be using the formula, just move this down. We're using formula distance, or sorry, not distance, speed or velocity is equal to distance over time. So if I'm going downstream, my speed or my velocity, which we've already found, right? Because we have a distance, velocity, and a time. Our velocity is P plus R is going to equal our distance, which was 12, over our time, which was 2. So the speed of the paddler plus the speed of the river has to equal 6 kilometers per hour. We don't really need to have that, but that's what that 6 represents. The second part, when we're going upstream, is going to be P minus R is equal to 12 over 3. Again, just getting that from our table. So our speed, the paddler minus the river, P minus R is equal to 4. Now I have two equations. So with those two equations, now we need to solve or solve this linear system or the system of equations. So we have our two equations. I'm going to rewrite them out. P plus R equals 6 and 2P minus R is equal to 4. P minus R equals 4 and P plus R equals 6. Now with these two equations, we can choose to solve with however we want. It doesn't really matter which way we solve, we should get the same answer either way. But again, it does lend itself nicely to a specific type. And in this case, it does lend itself nicely to elimination. And the reason being, the coefficients in front of the variables are the same. So if I line up my equations, P plus R equals 6 and P minus R equals 4. Now I just have to figure out which variable do I want to eliminate, because that will determine which operation I use. In this case, let's look to eliminate P. So if I want to eliminate P, I'm going to subtract because the variables, or the coefficients are the same sign. So I'm going to subtract these two equations. P minus P is 0, positive R minus negative R, or you could think of positive 1R minus negative 1R is equal to positive 2R. And 6 minus 4 is 2. And now I'm going to go through and solve my equation. 2R equals 2, R equals 1. Now we might just be able to do that in our heads, but if not, we're dividing both sides by 2 to get R by itself. Now that I've found R, now I can sub R equals 1 back into either equation. I'm going to plug it into equation 1 just a little bit easier. So P plus R is equal to 6. p plus 1 equals 6. And I don't even need to really show any work. What plus 1 equals 6? Well, p then has to equal 5. And now I have my two parts. So therefore, the paddler or the canoeist travels at a speed of 5 kilometers per hour, and the current is 1 kilometer per hour. So those would be our two speeds. Right? If we want to verify or double check, right, just to make sure our equation is correct, I'm going to look at my two equations. So p plus r is equal to 6. I already found my points to p equals 5 and r equals 1. So I plug those in. 5 plus 1 equals 6. 6 equals 6. That's good. On the other side, the second equation, p minus r equals 4. 5 minus 1 equals 4, and then 4 equals 4. So it does work for both equations, so this is the correct solution. Next example, again very similar, with a tailwind, or that means going downwind or with the wind. A plane flew 3,000 kilometers from Calgary to Montreal in 5 hours. The return flight against the wind or upwind took 6 hours. Find the wind speed and the speed of the plane. So again, right, when you're flying, the plane is flying at a certain speed, but if you're traveling with the wind, you'll go a little bit faster. And if you're traveling against the wind, you'll go a little bit slower. So if you've ever flown, sometimes you'll hear the pilot talk about how they're making they're traveling a bit faster, they're going to get to their destination a little bit quicker, and that will probably have to do with the wind speed, right? It's not like they're just holding back on the throttle. It might have to do with the wind speed and the air currents. So we're going to do something very similar to what we just did. We're going to have our two directions. So we have downwind or with the wind, or tailwind, and then we have upwind, which is going against it. Our distance in both is 3,000. We traveled 3,000 kilometers. The time it took, well, we have 5 hours when we're traveling with the wind and 6 hours when we're traveling against the wind. Our speed, we don't know the speed because that is what the question is asking us to find. Right? We don't know the speed of the wind or the speed of the plane. So let's set up our variables. We know what we're looking for. So let's let x equal, or let's keep it away from the x. Let's let p equal the speed of the plane. And let's let w equal the speed of the wind. So again, similar to the canoe, right? Downwind, I'm traveling with the wind, so my overall speed is going to be the speed of the plane plus the speed of the wind. And when we're traveling upwind, it's going to be the opposite. We're going to subtract the speed of the wind. Now we need to come up with two equations. Right? And our equations are going to focus on the velocity equals distance over time, because that means I'll already have isolated for my variables. My variables will already be alone. Now they might not be isolated for a single one, but it does give us a good starting point. So equation 1, we're going to look downwind. So speed is p plus w is equal to distance over time, or 3,000 over 6, and we can simplify that a bit. P plus W equals, sorry, not 6, 5. It should be the shorter of the two. We get 600. And then for equation 2, when we're traveling upwind or with the or against the wind, we have P minus W equals 3,000 over 6. So P minus W equals 500. Now we're going to go through and we're going to solve. Right, so again, the method is up to you. We have P plus W equals 600, and P minus W equals 500. Now again, we can choose to use substitution or elimination. Like I said before, it does lend itself a little bit nicer to elimination because the coefficients in front of the variables are the same, but it's up to you. So similar to the last lesson, we looked at one of each type. Let's look at substitution for this one. Substitution. Just wanted to make sure I spelled that correctly. So first things I need to do is rearrange. So I'm going to rearrange equation 2 for P. And I'm doing that just because by looking at it, I know that P is going to be the easiest to rearrange for. I move the negative W over, it becomes positive, and then I'm done. Right? If I rearrange equation 1, I'm going to end up with a negative, and then that in the end, negatives make it a little bit messy. So I'm just going to rearrange equation 2 for P. So P minus W equals 500. Move the W over, and I get P is equal to 500 plus W. Again, I don't need to worry about rearranging or anything because I'm just going to be substituting. Next, let's sub P equals 500 plus W into the other equation, so equation 1. So if P plus W equals 600, 500 plus W is equal to 600. I'm going to collect like terms, so I get, and I'm going to also at the same time move the 500 over, so I end up with 2W is equal to 600 minus 500, or 100. Go through and solve, divide both sides, divide both sides by 2. One side cancels out, and I end up with W is equal to 50. Now that I know one variable, I'm going to take that, and I'm going to substitute it back in. So I'm going to sub W equals 50 into, let's say, equation 1, just because it's a little bit easier to kind of work through mentally. So P plus W equals 600, the speed of the plane plus the wind speed equals 600. So if the wind speed is 50, so P plus 50 equals 600, that means P has to be 550. So just some quick mental math here. So therefore, the plane travels at 550 kilometers per hour, and the wind speed is 50 kilometers per hour. So here we found our two answers, the plane speed and the wind speed. Let's just double check our answer. So we're going to take equation 1, P plus W equals 600. So we have 550 plus 50 equals 600. 600 is equal to 600. That checks off. And then in equation 2, we have P minus W equals 500. We have 550 minus 50 equals 500. 500 equals 500. So that works. So I've found the plane speed and the wind speed. Our last example is going to be one of the trickiest, and this is because there is no resistance involved. There's nothing working against what we're dealing with, right? In the other ones, there was something working against it. Here, not so much. In his spare time, Mr. Liu likes to cycle. He rides partly on paved surfaces and partly off-road. He rides at 25 kilometers per hour on paved surfaces and 10 kilometers per hour off-road. One day he rode 41 kilometers in 21 hours. Then how far did he ride off-road? So this is a lot more different. This is different because there's a lot less information and we're looking for something else. So what we're going to be doing is we're going to be, again, looking at two situations. One, we're going to be looking at paved, and one, we're going to be looking at off-road. We have a couple different variables here, right? We don't know what we're looking for, again, is going to determine what our variables are going to be. So the first one is the question is, how far did he ride off-road? So because I'm looking for how far, that means I'm looking for my distances. So I'm going to let x equal the paved distance, and I'm going to let y equal the off-road distance. So distance for the one, we have x. Distance for off-road, we're going to have y. Speed, we know for paved surfaces it's 25 kilometers per hour. We know for off-road it is 10. And for the time in total, right, so this is going to be a little bit different because we only know the total time, which is 2 hours. Just like for distance, we only know the total, which is 41. So it's a little bit different because we only know totals. We don't know the individual components. But we can use this to kind of help us come up with our two equations. So the first equation is going to be an easy one. Our unknown distances, x plus y, has to equal 41. The part that's going to be a little bit harder is going to be the next part. This is going to be equation 2. And this is going to involve the other total, which is going to equal the time of 2 hours. So this is where the formula or our triangle comes into play. It's going to be very helpful, right? Because our 2 refers to time. And remember, the triangle is velocity equals distance over time. Because I'm looking for time, right? That means if I cover, if I cover time up, what's left over? Well, I have time is equal to distance over velocity. I do have a distance and I do have a velocity. And if I think of that, right, the distance and the velocity for each one, time or paved and off-road together, added up will give me the total time. Because if I can figure out how much time I spent on the paved road and how much time I spent off-road, that will give me a total of 2 hours. So to calculate the time for paved, I have to take the distance divided by the speed, or x over 25, and then I'm going to add the time off-road, which would be the distance, or y, over 10, which is the speed. And now I have a formula. What I can do, though, is I can make this a little bit easier. I can kind of work with the fractions. I can multiply everything by 50. A common denominator between the two. If I multiply everything by 50, or at least the numerators by 50, this will give me, so x times 50 is 50, but divided by 25 is 2, so 2x. Y times 50 is 50y, divided by 10 is 5y. And 2 times 50 is 100. So now we have our two equations. Technically we have three, but one is just kind of a rewritten version, so it's still the same. So now that I have my two equations, we need to solve by elimination or substitution, right? So it's up to you which one you want to do. I would say, again, either one would work because of how they're laid out, right? The coefficients in front of equation 1 are both 1, so that makes it really easy to multiply them to get to a specific value. It also makes it really easy to rearrange. So I could either do elimination or substitution. I feel like most people might like elimination, so I'm going to solve this one by elimination for you. Again, if you choose substitution, that's fine. You should get the same answer either way. So because it's elimination, I need to get one of the equations, or I need to get the variables the same. So I'm going to cancel out my x's. I'm going to multiply equation 1 by 2 to get 2x plus 2y equals 81. Now with equation 2 of 2x plus 5y equals 100, now I have the coefficients in front of x the same. Because they're the same sign, that means I'm going to subtract. I'm going to put brackets around the bottom term just so I remember to subtract everything. 2x minus 2x is 0. 2y minus 5y is negative 3y. And 81 minus 100 is negative 19. Sorry, not 81, 82. Some improper math there. 82. So 82 minus 100 equals negative 18. Now I have negative 3y equals negative 18. I'm going to solve for y, divide both sides by negative 3. One side cancels out. I'm left with y is equal to negative, or not negative, because the negatives would cancel out. We have positive 6. Now that I found y, I need to sub that back in. Sub y equals 6. I'm going to say into equation 1, just because it is an easier one. So x plus y, equals 41. X plus 6 equals 41. X equals 35. So now I have my two components. So therefore, he rode on, he rode 35 kilometers on paved and 6 kilometers off-road. So again, the steps of going through and solving by elimination or substitution aren't the difficult part of these word problems. The difficult part is being able to come up with the equations. So again, this one was a little bit different from the other distance time graphs ones, but as long as we started to go through, think about what the totals were, what our unknowns are, right? Very similar to some of the other questions, right? Your variables are probably going to be based off of what you have to find or what you're trying to answer. So you have to look for the question. If there's totals in your equation, in your scenario, like we knew we had a total of 41 kilometers in 2 hours, chances are those two are going to be what our two equations have to equal. So we have to figure out, okay, well, how can I use my variables to come up with a total distance? How can I use my variables to come up with a time or a total time? And the big thing about these distance time or these distance speed time questions is that they all kind of revolve around that uh, velocity. That velocity is equal to distance over time, and using that triangle dvt to help us come up with the other ones. So we might be solving for time, or solving for velocity, or solving for distance. So again, the tricky part is going to be coming up with the equations, but as long as you practice and kind of see different examples, different scenarios, it will become easier.